Hello, my Algebra 2 students. Today we are doing day 4 of Unit 10 about fractional exponents. So we're going to start it with the idea of how do we express a square root using an exponent? Because it can be done, it's just a matter of what does it look like. So what I want to start with is then saying if I take the square root of a, we're just going to use something generic, that would be the same as a raised to what power? Right? So our goal is to take this and solve for m. Figure out what that m value is. All right, I'm going to copy it down just so I can leave that initial line untouched. So what I want you to think of is, all right, well, if I want to get rid of a square root, what do? Well, we can come in and we can square both sides. So if I square the right-hand side, it means I would need to square the left-hand side. And so on the left-hand side, square root and a square, that'll cancel. I'll be left with a. On the right-hand side, power raised to a power, we would multiply. So I would get a raised to the m times 2, or 2m. All right. For the next step here, what I want to look at is, all right, well, my bases are the same. So this is an a, this is an a. That means the exponents have to be the same for them to be equal. The exponent on the left side, if I don't see it, is just a 1. That means at this point, I can actually set the exponents to be equal to each other. So I can take the 1 from here and set it equal to the 2m. And they should be the same if these are going to be equivalent expressions. All right, solve for m, just divide by 2, and m comes out to be 1/2. So what that means is that the square root of a is the same as having a raised to the 1/2 power. So let's try this out. If I use like a little example, if I do the square root of 16, well, we all know that that's 4. So that is the same then as saying 16 raised to the 1/2 power. Right? If you grab your calculator on your home screen, covering up things a little bit, but if I do square root of 16, there's 4. We knew that. 16, and now raise it to the 1/2 power. That also comes out to be 4. So those are interchangeable. They're equivalent expressions, which is kind of cool. Just something new that we can do here, right? The other thing we can do is we can extend this to any root. And what I mean by that, all right, if I think of a square root, well, why did it come out as a to the 1/2? Well, we know there's that little index value out here of 2. And the exponent on the a right there is 1. So you're just taking the exponent and dividing it by the root. If I then took a cube root of a, I could play the same game. There's an exponent of 1, dividing it by the root of 3. And then same thing if I were to do like a 4th root or a 5th root and so on. This would be equivalent to a to the 1/4 power. So in general, what the rule is that I can have a to the m power and then take the nth root, and it'll be equal to a raised to the m divided by n. Or more appropriately, I can kind of think of it as a raised to the power divided by the root. That's what you'll essentially end up with. So whatever the power is here, divided by the root out there. All right, if you got a colored pencil, box that baby in, star it, highlight it. That is our fun new fact for the day. So if we just do a few examples before we finish together here, we're going to use the fact that we can take any radical and write it as a fractional exponent so that then we can either simplify it from there or just rewrite it in a different format. So for this first one, if I give you the 7th root of x to the 24th, and I just say, let's rewrite these as fractional exponents. All right, well, this first one, nothing crazy. You're just going to take the power divided by the root, right? And in the case of 24 divided by 7, there's nothing you could do to it. So this would be it. This is just written with a fractional exponent. All right, if I give you the cube root of 36 to the 6th power, all right, rewrite it first. 36 raised to the power divided by the root would be 6 divided by 3. And now here's one that I can go a little further. 6 divided by 3 cleans up nicely to 2. And then I'm just saying, all right, what's 36 squared? So if we grab our calculators and do 36 squared, that would be 1,296. Done. So sometimes you're going to get it where you can clean it up a bit. Sometimes you're like, that's about as good as it's going to go. And that's okay. All right, let's do one more here. If I give you the 12th root of a cubed, same thing, power over root. And so in this case, 3 over 12. So sometimes the power is going to be smaller than the root. But what we could do is we could simplify. 3/12 would be the same as 1/4, right? And so this is actually the same as the 4th root of a. So that's just a little like sidebar over there. But a to the 1/4 would be our answer here. Let's do a few where we rewrite the fractional exponents as radicals. So for number 4, if I give you x to the 21/4 power, slightly crazy looking, but that's okay. It's good little practice. All right, first things first, power root. So make sure this goes here, this goes here. If I then said now simplify it, let me add that to our directions there. Think about what the heck we would do with this. For it to be a perfect fourth, this number needs to be a multiple of 4. And it's not, but I could break it up. So I could make it the 4th root of x to the 20th power, and then times the 4th root of x to the 1st. Here, this is nice and perfect because 20 divided by 4 would be x to the 5th, and then I'd be stuck with this guy. So that would be it in simplest radical form. All right, let's do one last one like that, and then we'll call it quits. So for this one here, excuse me, if we do x and then raise it to the 49/13 power, now you know we're just looking a little crazy just for sheer practice. So we'd have x to the 49th power. We'd be taking the 13th root. That is kind of nuts. All right, 49 is not divisible by 13, so rewrite it. The 13th root times the 13th root here. All right, so think multiples of 13. So 13 times 2 is 26. 13 times 3 is 39. That's about as good as it's going to get. So we'd have x to the 39th here. X to the 10th would be my leftover because when you add 39 and 10, it comes back to x to the 49th. All right, and then divide 39 divided by 13 comes back to x to the 3rd power, and then you'd be left with the 13th root of x to the 10. A little crazy, but it's just some good practice to show you can go from radical to exponent, and then you can go from exponent back to the radical if you need to.